Let's talk about how functions can be expressed verbally. A verbal description of a function: a quantity is multiplied by 7, and then 8 is subtracted from the result of multiplying. This describes a function. We have the quantity, this is our input, and then we do something to that input. So we're multiplying the input by 7, and then we subtract 8 from the result, and the overall result gives us our output. So we can use the rule to evaluate the function. Here's an example. Suppose the quantity is 5. So the quantity is multiplied by 7. 7 times 5 is 35. And then 8 is subtracted from the result of multiplying. So notice that wording. 8 is subtracted from the result. So we have 35 minus 8. And then the result of subtracting is 17, which is our output or our answer. And we got an answer, but it seems like it took us a little bit longer to find an answer. And I think it's because at this point, we have gotten used to using mathematical expressions and representing multiplication, division, addition, and subtraction using symbols. And that symbolic representation allows us to concisely describe a function. So we can convert those verbal instructions to an algebraic expression. The quantity is the unknown. We'll call it x. The quantity is multiplied by 7. So we get 7 times x. And then 8 is subtracted from the result of multiplying. 7x minus 8. And we end up with this function in symbolic notation. F of x equals 7x minus 8. So let's try to write functions that represent verbal expressions. So let's take A together, and then I want you, after we finish A, I want you to pause, try B on your own, resume, we'll talk about B, and then pause again and try C on your own, resume, and we'll talk about C. Again, testing your own ability to assimilate information and apply that information directly, because the faster that you can apply it, the easier it is for your brain to pick it up and make those corrections if we have mistakes. So that's why we want to try to do our homework as soon as we can after the lesson to try to apply it, but then also practice throughout the week. So maybe we don't finish all of the homework all at once. We look at a few problems, and then the next day we look at a few more. And just so that we can remind our brain, refresh our memory, and keep building on the knowledge that we're gaining. Okay, so part A. Write a function that represents the verbal expression. In each case, identify an input variable. So we'll let x be the input. We need to multiply a quantity by 9 and then subtract it from 11 to obtain a result. So let's take the first part. Multiply a quantity by 9. That's going to be represented by 9 times x. And then subtract it from 11. Remember in the last problem we just did, we said that we were going to subtract 8 from the result of multiplying. And we noticed that 8 ended up in the back. It ended up at the end. When we have this word from reverses the order in the English language. It takes the number in the front, subtract it from, it puts the it in the back. So we're subtracting from 11. We start with 11 and we're subtracting it from 11. And so that would mean we have 11 minus the result, 9x. 11 minus our multiplied quantity, 9x. And that would give us our result, our answer. So we can create a function. We already have a function f. Let's give it another name. Let's call it g. You can call it whatever name you want to. If you want to call it x or f again, that's totally fine. 11 minus 9x. The only time we really need to change our function name is if we're using multiple functions in the same place. So we may, or we're using one function to get another, and we'll talk about that in the future lessons from now. So it's okay to keep it as f or change it to something else. When we're working within one problem, it doesn't really matter what we name our function. So g of x equals 11 minus 9x. That would be the concise symbolic representation of that verbal expression. See if you can try b. Pause here, try b, and then resume and we'll talk through it. We can let x be our input again. We've got a quantity, that's going to be our x. and it says square a quantity. Square a quantity means we're going to raise it to the second power and then add it to 4. So x squared plus 4. Add it to 4. That's our function. We just need to give it a name. h of x equals x squared plus 4. Square a quantity and then add it to 4. Okay, try C. Pause it, try it, and then we'll resume and talk through it. Divide an input by 3 to obtain an output. Well, our input's going to be x. Divide an input by 3. Divide by 3 to obtain an output. We'll call this one f of x again. f of x equals x divided by 3. Awesome. Okay, now we switch it around. In number 2, we have a function, and this time we need to write a verbal statement for the function. So we're going to write in words what these expressions mean. Notice in all of the previous ones, we started with the quantity. What do we do with the quantity? So in this first problem, our quantity is x. What do we do with it? Immediately, we're multiplying by 4. So let's write that down. Multiply a quantity by 4, and then what's the next step? After we multiply it by 4, we subtract. But what do we do to the quantity? Where's the quantity coming in? It's coming in at the end of the subtraction, right? We're subtracting from 3. We could say subtract the result from 3. So we multiply a quantity by 4 and then subtract from 3. 3 minus 4x. Good. How about the next one? Looking at G, we start out with the quantity. It's being squared. Then what do we do with it? We divide that by 3. Square the quantity, and then divide the result by 3. This idea of verbal representations of functions and being able to switch back and forth between the words to the expression or the expression to words, it can really help us with the application problems that we have. Now remember, one of the main purposes of mathematics is to model the world around us. And in order to model our very language-centered world, is to convert that language into mathematical symbols that we can then apply. So having the skill, being able to take the symbols and write it into words, or take the words and write it into symbols, it can really help us when we're trying to solve real-world problems. In the very last part of this section, we're going to talk about those domains in the context of symbolic representations of functions. When it comes to finding domains and ranges, we've been using tables and ordered pairs and graphs to find that domain and range. But what if we only have the expression? What if we only have the symbolic representation of the function? Can we still talk about finding the domain? It turns out we can. Finding the range with symbolic notation takes a little bit more practice with these functions, so that is not something at this level that we'll be working with. We're just going to be focusing on the domain for these functions. Range will be asked for tables and ordered pair sets and graphs, but not for symbolic representation. Domains will be asked of all of them. So in the next lesson, let's look at the domains of symbolic representations of functions. And it actually turns out we can classify functions into different types, and that alone can really help us with finding the domains for these symbolic representations.